Hello and welcome to our March Spotlight Webinar with Syxsense. Today we have our industry expert, Graham Brooks, here to give us an inside look into vulnerability remediation, presenting the process of scanning for a specific vulnerability and then remediating and reporting on that vulnerability. And with that, Graham Brooks.
Thanks, Joe. All right, so today I'm actually really looking forward to this content because we have some actual stuff to do, some actionable work that we can accomplish through Syxsense that you can see how we can hopefully simplify and also extend your functionality for your organization around vulnerability management. Before we jump into the console though and show you what that looks like, I want to take just a couple minutes to walk you through some definitions so you understand all the language I'm going to be using today. To that end, the first thing we need to address is the basic identity of what a vulnerability is. And per Microsoft, a vulnerability is a weakness in a product that could allow an attacker to compromise the integrity, availability, or confidentiality of that product. Now, there's some words there at the end: integrity, availability, and confidentiality. Those are kind of the key characteristics of cybersecurity. You need to have your data be integral, aka it needs to be stable and trustworthy, and it needs to be known information. Availability, it needs to be accessible by the people in your organization. And then confidentiality, that was pretty obvious. It needs to be private. You don't want personal identifying information just floating out on the internet. Vulnerability is something that compromises those three key functions of security. Another word that's important here is weakness. This isn't something that is designed into the product usually, although those do exist. Vulnerabilities traditionally are something where a programmer or a systems analyst has built a tool that does its job hopefully well, but they didn't account for something in the way they built it. And that lack of product functionality, or perhaps a weakness in how it was built, allows someone else to compromise that product or feature or function to give them access to things they shouldn't have access to. That's the confidentiality, integrity, and availability aspect. All right, so that's what a vulnerability is. In the industry, we have a few key tools that we use to organize, represent, and understand the kinds of vulnerabilities that we face as IT practitioners. The first of those key organizational tools is going to be the Common Vulnerabilities and Exposures Framework. It's also called CVE. CVE is essentially a classification program that allows you to understand who a vulnerability is. Each CVE is going to have something like CVE 2021 for the year, and then -00245, whatever. That's representing the specific identity of that vulnerability. And then embedded in that identity, there's a framework that's process that kind of tells you who owns this vulnerability, what other organizations have referenced this vulnerability. It kind of gives you just, if you want to think of it in terms of legalese, it's like a passport. It kind of just gives you information at scale about this particular issue. And then alongside the CVE, there's another framework that's really helpful. It's called the Common Vulnerability Scoring System, or CVSS. CVSS is a tool that looks at CVEs and explains how important each CVE is based off of those three key attributes of vulnerability that we talked about a few moments ago, those being availability, integrity, and confidentiality. The CVSS score looks at the vulnerability and says, okay, how big of an impact does this vulnerability play against the integrity of the system or information? Or how much exposure does this vulnerability cause to allow people to see information they're not supposed to? And so based off of how severe or insevere that vulnerability is against those specific issues, the vulnerability could be ranked higher or lower. There's a whole bunch of other components that make up the CVSS score. And if you're interested, I don't actually have the specific webcast in front of me, but if you go back a year or so, we at Syxsense did a fantastic webcast just covering CVSS scores and CVEs, and kind of explaining how that framework works, and then also how you can apply that to your organization. All right, so those are two industry standard understandings that we need to have around vulnerabilities. There's another two kind of concepts I want to cover real quick that are potentially a little bit more case specific to Syxsense, because different organizations will classify things in a different way. The first of those two are going to be our patch vulnerabilities. So we classify vulnerabilities in two separate categories, one being patch vulnerabilities and the other being configuration vulnerabilities. Patch vulnerabilities, it's basically looking at a software package and saying, Google Chrome, you were found to have an exploit available last week. And this week, Google released an update to you that changes your version identity from, I don't know, 107.2 to 107.25. And if you deploy that executable, that patch to the device, it will remove that vulnerability. And the vulnerability most likely is a CVE that's referenced by organizations like MITRE and NIST and other organizations that track configuration and patch vulnerabilities. So in essence, patch vulnerability is something where you deploy software and it fixes the issue. So that's one class. And then, as I mentioned, the other class is going to be configuration-based vulnerabilities. All of the things that in order to fix, you have to change some sort of functionality in a tool. An easy example of that, though it can be nuanced because most of the configuration vulnerabilities that exist have some interplay with patch content. If anyone remembers the Felina vulnerability from, wow, last year, it's been a while. There was an issue where people could gain access to permissions they weren't supposed to using the Microsoft 365 product suite. And it was found that most of the issues revolved around the support diagnostics platform within Microsoft 365. If you turned off Microsoft 365 support diagnostic tools, that would mitigate that configuration vulnerability and allow your organization to essentially restrict that vulnerability from being exercised in your environment. Great. It's a configuration-based vulnerability. Now, a couple of weeks later, Microsoft released a software patch, so a traditional patch vulnerability that fixed that configuration issue that allowed people to turn their support diagnostics tool back on. So there's a lot of interplay between patches and configuration-based vulnerabilities. But we generally do put them in one or the other classification. And then as the situation changes, we might migrate it from being a configuration to being a patch. Another vulnerability that is purely a configuration vulnerability would be something like a user account that's an administrator that's not supposed to be. This is looking more towards like your CIS benchmark, which is a whole nother conversation we can have at a different time. But you have all of these configurations that you just want to set to predefined stable baselines. A great tool for analyzing your baseline is going to be the NIST framework 27001. It outlines all sorts of requirements that most industries are going to want. to set as defaults. And then if something doesn't match that default, like an administrator account who's a local admin who shouldn't be, you can then key off of that issue and then fix it dynamically using Syxsense, which is actually where we are going to go next. So bear with me while I stop sharing my screen for a brief moment. We're going to jump into the Syxsense console, and I'm going to show you how we can analyze vulnerabilities, how we can report on vulnerabilities, and then also how we can deploy remediations against vulnerabilities. So first, a little bit of an architecture lesson so you understand the content that we're showing today and how we're able to manage that content on your devices. Syxsense is a cloud-hosted platform in Azure, and we use an agent-based deployment method to provision your endpoints, to manage them, to report on them, to identify issues with them. The agent is going to communicate in real time back up to the Syxsense console with telemetry data as the environment changes. I'm going to give you a really simple example of what that looks like. To do that, I'm going to go over to my Devices tab here on the left-hand sidebar of my platform, and then we're going to take a look at one of my default queries. So here under default queries, I have this recently discovered query. And this simply describes endpoints that are new in the console, devices that have just been added that may or may not have policies assigned to them yet. So that's kind of my framework for recently discovered devices. I then pair that list of assets with a policy that automatically deploys work against those devices. So here, if I go into my intelligent endpoint provisioning set of workflows, I have a workflow that describes my patch and configuration compliance. And this is something that just runs automatically on my devices, especially against new endpoints. So the moment a device comes online, we start doing this query against the endpoint, looking for patching issues and looking for configuration issues. It's essentially a vulnerability scan, if you're familiar with that terminology. Once we run that vulnerability scan, if we find anything that is important, we will then mark the device as untrusted, so limit that endpoint's access to resources, whether that's a website or perhaps you don't want them to use Outlook for a time being. We're just going to kind of limit their ability to do work from this environment. Then we'll push work down to the device, install updates, configure vulnerability remediations. We'll then run that same query against the device again, make sure that this endpoint is healthy and safe now, and then we'll mark it as trusted again. And where we're going to spend our time today is focused around two key components. First, this health query. How do we generate that? What does that look like when we're actually pulling information from the device? And then this remediation. What does it look like to deploy work to an endpoint? And how does that work get done? Both of those components are going to live in our vulnerabilities library. So at Syxsense, we actually maintain a collection of both patch and configuration-based vulnerabilities. These are all definitions of things that are concerns that you might want to fix in your environment. If I open up my patch library, you'll see that we have a super verbose list of content for Windows, Mac OS, and Linux. And each of these items might also have CVEs associated with them. Those are the common vulnerability identities that we were talking about. So here, this is my definition for this particular patch. We can see that it does, in fact, have some CVEs associated with it. In fact, it's a critical vulnerability, though it is pretty old. So most of your environments shouldn't need this particular vulnerability fixed on them anymore. So that's kind of an example of one of the vulnerabilities that we have in our environment. But that's not really descriptive of what we're dealing with today, because we want to look at issues that are actively affecting our environment so that we can create positive change and resolve those issues. To do that, I'm actually going to drop into my queries list. From here, I'm going to look at my filtered vulnerabilities list, and we're going to take a look at my applicable priority security remediations. So this is a list of vulnerabilities that are high priority, that are currently affecting my environment, that I know that I have the ability to resolve today. You can see that I have 3 issues that I can deal with. The first is there's a password complexity requirement that's disabled. So if a user changes their password on their device, they can change that password to whatever value they want, like password 12345, without any intervention from an administrator, without that function being locked down. That's not good. The second item is DNS resolver spoofing. So essentially, someone could provision a setting on the device, allowing them to change where google.com resolves to. So they could create a fake website that looks exactly like google.com, but has extra code in it that would allow them to start key logging maybe on the websites you're visiting, or doing all sorts of nefarious things to you and your information. Also bad, you also want to fix that. And then automatic sign-in after system-initiated restart. So if a device reboots, it'll let you automatically sign in, which might be fine in some contexts, but that could allow someone who has unauthorized access to the device to restart the endpoint and gain entry into the end user experience without having to put in a username and password. So that's also an issue that we should resolve. So what does it actually look like to fix these vulnerabilities? If I click on this item right here and open up the overview here, I can see that I do have a device that's currently affected by the vulnerability. And I also see that I have some content here on the sidebar. In particular, we're looking for our resolution workflow. This resolution workflow is a process that has been built by the team at Syxsense, and it describes the process of remediating this particular vulnerability. We start by defining the issue. Let's scan the endpoint, query it for this vulnerability, and if we can find it, let's then trigger a C# script. This is something, again, written by our team. It's fairly in-depth, and it just goes through, I believe in this case, we're looking at some registry keys. Yep, you can see there, HKey local machine. And we're telling the registry to turn off the automatic sign-in function. And then once we have turned off that function, we're going to reevaluate the same device against the same vulnerability, just to see if that issue is still relevant and present. If it is, we will start sending out alerts, potentially as per that previous example, quarantining or disabling trust on that device so that it can't access resources, while someone from the sysadmin team goes through and maybe deploys some remediations manually if the system isn't able to catch it directly. Okay, so that's what the remediation path looks like. But how do I actually fix it? What does that look like to deploy that remediation? Well, in Syxsense, we actually don't like deploying standard tasks. We don't want to just push work on an ad hoc basis because it's not repeatable and it can slog down over time if you have lots of devices that you're trying to manually push work against. Instead, we prefer to use a policy basis for management. So you would run work as an ongoing process. And in this case, I'm going to create a remediation that deploys out against the vulnerability that we just looked at. And so here, I'm going to create a new blank automation, a Cortex workflow, and it's going to be just a single action. It's not complex. It's not difficult. We are simply resolving that individual vulnerability that we just found, which I believe is our password. Let's see if I can find it. There we go. All right. So if we have that password vulnerability issue, we can then automatically find it, resolve it, and revalidate it. And I'm going to set this to run periodically. So I'm going to call this continuous compliance password complexity. All right. So that's my vulnerability remediation. It's just one very simple step. And now I'm going to create a policy that's wrapped around that vulnerability remediation. And I'm going to tell this to run on an interval. I'm going to set this interval to run, let's say, once every 3 days. We don't need to run this all the time, but if you were really concerned, you could absolutely increase that duration. There are some organizations that run specific vulnerability remediations on an hourly or even every few minutes basis, because they know they have users who are non-compliant to their standards, who might not want to become compliant to their standards. All right, so we've created a time once every 3 days. Now we need to set a list of devices that we want to run against. Here, I'm going to keep it very simple and just say deploy against all assets under management. So any device that's available at any time, once every 3 days, just tell me about that device. See if there's a vulnerability associated with that password complexity. And if there is, resolve it whenever it's found. Okay, so now we have a policy in place. If you want, we can actually open up our previously ran policies, and we can see the resolution state. It looks like this particular policy is still loading down to my devices, so it might take a couple minutes, but once it's deployed across all 75 endpoints in my lab, it's going to then start publishing that remediation to those devices, dynamically removing that configuration issue as it's found. Which, by the way, is a drastically different process of doing work than the traditional vulnerability compliance portfolio, where you have a security team who's generating reports that show the vulnerabilities, that then they hand over to the operations team, that then reviews those reports, that then fixes those vulnerabilities. And that whole process usually takes a month or even longer to resolve. And unlike a GPO, which this is kind of replicating some of that functionality, where it relies on domain access and it relies on the device being available to communicate to the domain before it can even initiate that work. We're actually going to do all of this in real time through our agent-based solution that has real-time access to the console, regardless of what network it's on. So all we need is a network connection, and that allows us to communicate the needs and requirements. Okay, last thing I want to show through this process for today is the outcomes. What does it look like in a report to see a vulnerability and maybe see the vulnerability remediated? So first, let's look at our security vulnerability risk assessment. This report is going to provide detail into which vulnerabilities are currently present in our environment and which vulnerabilities need to be resolved. And unfortunately, it looks like my console might be having some lag. So I'm going to see if I can quickly go off share and deploy it separately. So just bear with me for a brief moment while I grab that report. All right, cool. So I'm going to share out a different console screen. There we are. All right, so this is my patch risk assessment. This is going to show you kind of an overview of which environments exist today and which environments have issues. So you can see a timeline of compliance against a particular environment. I think here we're looking at one of my server labs, and we can see that I've got 1.9 missing patches on average for that server lab. And I have a timeline of compliance. So I can see month to month how many patches are missing. We've got 5 on average here in October, and then fully patch compliant during other time constraints. And so that's going to give me a useful overview from a patch perspective. And now that it looks like my other environment has loaded, we're going to jump in and show you what the configuration side of that table is going to look like as well. So here we have our security vulnerability risk assessment that provides an overview of the configuration side of the house. So what I just showed you was patching, and this is now configurations. As we saw earlier, there were those 3 high priority vulnerabilities that need to be fixed. You can see when they were first discovered, and we can also get a trend line of how many are being discovered over time, as well as what vulnerabilities are affecting which environments. And we can even, if you want, show you that detail on a device-by-device basis. So I have other reports that'll show off which vulnerabilities exist or which vulnerabilities have been resolved, and then even what CVEs are associated with those vulnerabilities and what priority do those vulnerabilities have in your environment. All right, so that's the primary content that I wanted to show today during our webcast. If you have any questions around the tool set we've displayed, or if you're interested in taking a deeper dive into the platform, I'd love the opportunity to have a one-on-one conversation with you. So if you want, please reach out to whoever invited you to this session and schedule a time to talk to me and to someone from our team. Thank you so much and have a fantastic rest of your day.